Okay, I'd like to talk to you about oxidizing agents and reducing agents. An oxidizing agent causes something else to be oxidized. A reducing agent causes something to be reduced. So if an oxidizing agent causes something to be oxidized, that means it pulls electrons from something. So I'm going to write the oxidizing agent here. And let's say it's going to cause sodium to be oxidized. So that means it's going to cause an electron to go away from sodium, making sodium positive. So notice that the oxidizing agent, the thing that caused the sodium to be oxidized, is itself reduced. So oxidizing agents are reduced. On the other hand, a reducing agent is oxidized. So a reducing agent is going to cause, say, chlorine, a chlorine atom, to be reduced. It's going to lose an electron itself. So it's going to get rid of an electron. So it itself is oxidized. So the thing that causes the oxidation ends up itself getting reduced. So oxidizing agents are themselves reduced. A reducing agent is something that causes something to be reduced, and it itself must lose an electron, so it's oxidized. We're going to go through a couple problems here to see if we can identify oxidizing agents and reducing agents. Let's look at these equations here. I'm going to zero in on these substances here. If you run through the oxidation numbers on these, you'll see that hydrogen is +1 in hydrogen peroxide and oxygen's -1 in hydrogen peroxide. And you'll also find that in permanganate we showed that manganese is +7. In oxygen, that's an element, so that's going to be 0. So notice here that our oxygen in peroxide goes from a -1 to 0. That's an increase in oxidation number, and so hydrogen peroxide gets oxidized to oxygen. On the other hand, the permanganate, it gets reduced to manganese 2. And this should always be the case. Something gets oxidized, something else gets reduced. As I look at this, I'll notice that the hydrogen peroxide, which was oxidized, caused the reduction of permanganate. So hydrogen peroxide, which is oxidized, is going to be the reducing agent. And then the permanganate, which was reduced, it caused the oxidation of the peroxide. So the permanganate is going to be the oxidizing agent. In this case here, in this reaction, I minus goes to iodine. It looks like iodide is oxidized to iodine. And it looks like that hydrogen peroxide is reduced to water. So the iodine is oxidized, and it causes the reduction of peroxide to water. So it looks like iodine is the reducing agent, whereas hydrogen peroxide is the oxidizing agent. Let's look at this one here. In this case, zinc is going from zinc metal, which is going to be zinc 0, to zinc 2 plus. That's an oxidation. You're going up an oxidation number. Copper 2 ion is going to copper metal. That's going to copper 0. This one's easy to see. This is probably the easiest one, right? The zinc is oxidized, so it's the reducing agent. The copper is reduced, so it's the oxidizing agent. The copper 2 causes the oxidation of the zinc metal. The zinc metal causes the reduction of the copper ion. This particular reaction here is a very interesting one. I usually perform this reaction in class when I show this particular reaction. I'd like you to find what is the oxidizing agent and the reducing agent. I don't know which is which. I'm just underlining them here to help you maybe see which might be which. But I'd like you to look at try to figure out what is the oxidizing agent and the reducing agent in this particular reaction. And it's an interesting reaction because it's dissolved silver ions reacting with glucose. And this reaction of the silver ions with the glucose, it actually produces silver metal. And you can actually mix you can mix silver ion with glucose in the presence of a base, and you can form a silver mirror on the inside of a beaker. And y'all might have seen on the outside of my office door something called the Silver Beaker Award. It's an award I give every year. And it's given to the student who, at this point in the semester, who has scored the best in General Chemistry 1 and General Chemistry 2. And this year, I'm going to award the Silver Beaker Award to Jessica Panchot. Congratulations. Your name will be included on the list. And when you watch the video where I actually perform this reaction, there's a flask that I make that has a silvered mirror in it. And when we get back to campus, I'm going to give you that silver mirror. So make sure you drop by the office and pick that up. Congratulations, Jessica, on a job well done this semester. And for all of you, you're all doing great. Hang in there. Keep up the good work.